Morning students, let's continue the chapter thermodynamics. In previous lecture, we have seen the PV diagram. In that PV diagram, we have seen the thermodynamic state, they are get changed. What is thermodynamic state? These state variables PVT, they refer the thermodynamic state. And if any one of the state variable, for instance, let us consider the volume, is get changed from the initial volume Vi to Vf, then we say that the thermodynamic state is also get changed. The thermodynamic state is get changed. The change in volume is occur in two different ways. Now let us see. One way which we have already seen. Let us consider a cylinder. This cylinder is having an movable, then the frictionless piston, and gas is enclosed in it. Suppose Vi be the volume of this gas which is enclosed in this cylinder. Now with the help of external source, we supply heat to this cylinder so that this gas start expanding slowly, and as this gas start expanding, it exert force on this piston, and so this piston is moved in upward direction, and now these are the new positions. In this new position, the volume of gas is Vf. In this process, heat is absorbed by the system and work is done by the system. The state is get changed from volume Vi to Vf. Now let us consider the another way of achieving the final state. Suppose we are having this cylinder, and this cylinder is surrounded by an non-conducting material. So it is insulated. This non-conducting material does not allow the exchange of heat between system and its surrounding. The system is not enter the heat is not enter from system to surrounding, or the heat is not enter from surrounding to system due to this insulating material. Now let us consider there is an breakable piston. This is the breakable piston which divide this into two part. This is the lower part and this is the upper part. This part is having volume is equal to Vi, and this upper region is empty. Now this breakable piston is broken. When this breakable piston is broken, then the gas suddenly get expand and it entered in this empty portion. It occupies all the volume. So the final volume is same as this case. This is the final volume Vf, and as it is surrounded by the insulating material, the heat is not allowed to exchange to the surrounding. We achieve this final state in two different paths, in two different ways, by adding heat and by not adding heat. Here we may conclude that heat transfer to a system also depend on the temperature. What do we conclude? Heat transfer to a system also depend on the way, the path. Okay, in this path the heat is get transferred to the system. And now let us see the classification of thermodynamic processes. The thermodynamic processes, they are get classified into different ways. Suppose the first one is the reversible and irreversible process. Let us see PV diagram. Suppose this is the PV diagram. This is P, this is V, and this is another PV diagram. This is P, this is V. Now this is the initial state, this is the final state, this is state A, this is state B. Again let us consider here, this is the initial state, this is the final state. Suppose the system changes from this path, from A to B. This is the path which is followed to occur the change. And similarly here, same is the path from A to B. Now the systems are get classified into reversible and irreversible processes. If we can able to retrace the same path again, then we say that that process is reversible process. And if we are not able to retrace the same path, then we say that the process is irreversible process. In reversible process, the path that can be get retraced in reversible process. The path can be retraced in reverse direction, and in the irreversible process the path cannot be retraced in reverse direction. The example of this irreversible process, that is the boiling of water, melting of ice, these are the examples of this reversible process. Now why we are not able to retrace the path? That is due to two reasons. There are two reasons of irreversibility. The first is the free expansion. In free expansion, the system is not in equilibrium. The system is in equilibrium, and that's why the path cannot be get retraced again in the same direction. And the second cause of this irreversibility is the dissipative forces. The dissipative forces like the friction, like the viscosity, there are some permanent changes, and that's why the path cannot be retraced again. Now in further discussion we are going to see these reversible processes, means that the paths they are the same. Now let us see for the further discussion of these thermodynamic processes some assumptions. The assumptions for discussion of thermodynamic processes. Now let us see some assumptions. The first assumption is the thermodynamic processes, they are reversible. They are reversible. The thermodynamic processes, they are reversible means the path can be retraced again. The systems, they are in equilibrium. For the further discussion, we assume that the processes, they are occur in equilibrium state. The processes, they are occur in equilibrium state and simultaneously they change in state. How it is possible? It is possible by considering the quasi-static state. What is quasi-static state? Quasi-static state is defined as a process. What is this quasi-static state? It is a process in which changes, in which changes in state variable, in state variable. Which are the state variable? The pressure, volume, temperature, these are the state variable. The state variable of a system, of a system occur, the state variable of a system occur infinitesimally slowly. The state variables like volume, pressure, they occur infinitesimally slowly. Suppose this is the state A, and we wish to go to this state B. Then in quasi-static state, we go infinitesimally slowly. We get the neighboring state. This is the neighboring state, then the neighboring, then the neighboring state, then the neighboring, and these are the different states. Okay, and in these quasi-static states, the system, the change that get occur for these consecutive states, the changes, they are very small. There is very small change in the pressure, there is very small change in volume. Such systems, they are known as the quasi-static states. Then the second assumptions which we are going to assume for further discussion is, we are considering a cylinder. So and the cylinder is having the piston which is movable, which is massless, and which consists of an ideal gas. This cylinder, in this cylinder, an ideal gas is enclosed. And also we are going to consider the temperature that is the same. And our third assumption is the ideal gas equation is applicable to the system. Ideal gas equation is applicable to the system. So these are the assumptions which are required for the further classification of thermodynamic processes. Okay, thank you.